Welcome to this video on graphing lines by generating points and graphing lines using x and y intercepts. Let's begin. In a previous section, we have learned how to fill out a table of x and y values if we are given the equation of a line. So here's our equation right here. It says y is equal to negative x. So in the past, we filled out the table when it was populated with numbers something like this. Right? And sometimes you're given the x value and sometimes you're given the y value, and then we had to fill that in, and we know how to do that. So this time we're going to do literally the same thing, only this time we have a little bit more freedom, because what we're going to do is we can pick any value we want for x. So first of all, we want to make sure we pick values of x that actually will fit on the graph that we're given. So here is my x-axis, here's my y-axis, right? So the x-axis goes from 1, 2, 3, 4, 5, 6, 7. So it goes all the way up to positive 7, and then it also goes all the way down, it looks like, to negative 7. Okay, so the values that I need, that I choose for x should be between positive and negative 7. So let's just pick a really easy one, right, which is 0. Because 0 is just probably the easiest number to work with. So if y is equal to negative x, right, then y is equal to negative 0. Well, 0 can't be negative, right? So we would just say that y is equal to 0. So that means one of the points on this graph is going to be 0, 0, right? It's going to be the origin, okay? And if you're like, where did I get those numbers, right? Well, we got this 0 from here, and that 0 from here. In other words, this is the ordered pair 0, 0. Okay, so we could pick any other number that we want, right? So another easy number to work with is 1, right? So I could also pick 1. Okay, so if x is equal to 1, well, y is equal to negative x, so y is equal to negative 1. So then we have the ordered pair 1, negative 1, which is right here. Okay? Now, if you're graphing with pencil and paper, you might want to continue and generate more points. And I'll talk about that in another video, in another course, or sorry, another class, in a subsequent video, why that's important. Okay, but especially if you're using online software tool, it really only takes 2 points to create a straight line, right? And that software tool is going to be perfect, whereas your pencil and paper might, there might be a little bit of error when you're drawing it, especially if you're freehanding it. Okay, but with a software tool, what we can do is we can go ahead and ask the software tool to generate the line just using these 2 points. Okay, and let me draw over them in black so you can see them better. So again, the 2 points that we had, one was right here and the other one was right there. Okay, so just so you understand, I happen to pick the points x equals 0 and x equal 1. Okay, I could have also picked the number 2. Right? So if I let x equal to 2, well, y is equal to negative x, so then y would be equal to negative 2. So that's the point right here. I could have picked x equals negative 4. Well, if y is equal to negative 4, right, remember minus a negative is equal to plus a positive, right? So that would be negative 4, 4, which is this point here. Right? Notice all these other points are still points on the line. Again, the reason we stop, or we can stop after 2, is because it only takes 2 points to form a straight line. All right, let's do some more examples. So the next one says 2x minus y is equal to 6. Again, we can pick any value of x that we want to, as long as we are working with the range of values that are displayed on our little graph here. So we want to stay between negative and positive 7 so that it fits on the graph that we're given. Okay, so again, easy number to work with is 0, right? So remember y, it says, well, this is interesting. Well, we don't have y equals anything, do we? No, we have 2x minus y is equal to 6. Okay, so I guess we're going to have to put 0 in for x. So we'll have 2 times 0 minus y is equal to 6. Okay, well, 2 times 0 is equal to 0, so we have 0 minus y is equal to 6. Well, is this the equation? Is it that y equals 6? Well, not really, right? Because we have this negative sign here. And another way to think about that is that it's negative 1 times y. So how do we get rid of that negative sign? We have to move it to the other side in order to have y equal something. And the way we do that is that we divide both sides by negative 1. So we find out that y is equal to negative 6. So I'm going to write that there. So my first ordered pair is the ordered pair 0, comma, negative 6. Okay, and that's going to be right here, I believe. Okay, So that's our first ordered pair. Again, that's the point 0, -6. Okay, so let's pick another number. So again, you can pick any number you want. I'm going to pick 1 for simplicity's sake, just because 1 is an easy number to work with. Okay, so I'm going to erase this just because, as you can see, I sort of kind of ran out of room. So now I have 2x minus y is equal to 6. This time x is not 0, right? I chose instead 1. So we have 2 times 1 minus y equals 6. So we have 2 minus y is equal to 6. So now what do we have to do? So this is where we have to pull back our skills of solving linear equations. Well, I'm going to subtract 2 from both sides. That's the first thing I'm going to do. And remember this negative sign next to the y. He's still there. It's not y is equal to 4. It's negative y equals 4 or negative 1y equals 4. Okay, so to get y all by itself, we have to then divide by negative 1. Okay, and we find that y is equal to negative 4. So my next ordered pair is the ordered pair 1, negative 4. So the ordered pair 1, negative 4 is right there. Okay, so now, right, I have 2 points, and I can go ahead and graph my line by connecting those 2 points either with a pencil, paper, and ruler, or on the computer. Okay, so again, you could do more work if you wanted to. You could generate extra points, but again, it only takes 2 points to form a line. All right, let's look at example 3. So again, we have an equation. We have 2y equals negative 6. Okay, so this is an interesting equation. Take a minute, pause this video, and see if you can see what's very different and unique about this equation relative to the other equations we've been looking at. Did you notice that there's no x value in there? We have 2y is equal to negative 6. If I wanted to solve for y, I could divide both sides by 2, and I find out that y is equal to negative 3. Well, now I'm very perplexed because I have a value for y, which is negative 3, but I don't have any value for x. So how on earth can I generate an ordered pair? What should I do? Well, the secret is that y is always negative 3. And the crazy truth is that x can be anything I want. It could be negative 4 or 0 or 2 or 3. X can be any value that I want it to, and y is always going to be negative 3, right? Because y is a constant. So I could take any of these ordered pairs, or one that I didn't even write here, and plot them on the graph. So let's just randomly pick this one. So negative 4, negative 3 is right here, right? 0, 3 is here, right? And if you look at these 2 points, what kind of line are they going to form? Well, they're actually going to form a horizontal line, aren't they? Right? Because again, this is the line y equals negative 3. And just in case you're having doubts or worries, you could also plot the point 2, negative 3, and 3, negative 3, right? And you would still see that all of those are points on this line. So let's do one more example. So now we have the equation 3x equals 6. So once again, this is a little bit unusual for an equation. Do you see what's unusual about it? Well, the fact is there's an x represented in the equation, but there is no y value. In fact, I can solve for x by dividing both sides by 3, and I find that x is equal to 2. So I know that x is going to be 2 no matter what. But what is y going to be? Well, the cool thing is that y can be anything. Now remember, on this grid, y only goes from positive 7 to negative 7, or negative 7 to positive 7, however you want to say that, right? So I should probably pick values that are going to fit on my graph, right, that fit in this window. So we can pick any value you want, negative 2, 0, 1, 5, right? Like any number between negative 7 and 7, right? I can assign y any number, and it's going to be true, because x is always 2. So let's go ahead and plot these. So x equals 2, y equals negative 2, that's right here. Okay, let's see, 2, 0 is right here, 2, 1 is right here, 2, 5 is right there. Okay, again, you only have to plot 2 of these points. I just did some extra work just so that, you know, it would hopefully be helpful and obvious what I was doing. I apologize, I'm having a little bit of trouble making the software do what I want it to do. I think I'm going to have to draw this line by hand, even though it's going to be a little bit shaky, because it wasn't snapping to vertical. So there we go. So as you can see, the line x equals 2 is a vertical line. Okay, and again, we can assign y any value we want to, and no matter what value we assign for y, x is just going to be 2. That's it. So the second topic we want to cover in this video is how to, first of all, what are x and y intercepts? We want to introduce that concept, and then to teach you very simply how to use the x and y intercepts to also generate a graph of a line. So the x-intercept is the place where a line crosses the x-axis, as the name suggests, right? So if I look at this picture here, right, here is the blue line, right? And the blue line is crossing the horizontal axis at the point 2, 0. So 2, 0 is the x-intercept. The y-intercept, as the name suggests, is the place where a line crosses the y-axis, or the vertical axis, right? So here is my blue line right here. Right, where it crosses this vertical axis or y-axis is the point 0, -4. So 0, -4 is the y-intercept. Okay, and we have a really simple, quick way to find both intercepts. In order to find the x-intercept, we are going to set y equal to 0 and solve for x. And in order to find the y-intercept, we're going to set x equal to 0 and solve for y. So let's do a few examples to get comfortable with this process. So you might notice that this setup for this example looks pretty much the same as the previous examples we did, right? We still have a table, don't we? And we still have a graph, okay? So the only difference between doing the x and y intercepts and all the previous examples is that I don't get to choose willy-nilly different values of x, okay? For the x-intercept, remember, to find the x-intercept, we have to set y equal to 0 and solve for x. So that's going to look like this ordered pair here. Okay, so y is equal to 0. I have to find this mystery value of x. Likewise, to find the x-intercept, to find the y-intercept, I apologize, we need to set x equal to 0. Okay, so we're going to set x equal to 0 and then find what y is. Okay, so again, in previous examples, we got to pick any values we wanted, any 2 points. This time, I'm telling you what 2 points you have to use. You have to use the x and y intercept. Okay, so these are the 2 points that we're going to use to generate our graph. All right, so let's go ahead and get started finding the x-intercept. So our equation is 3x plus 4y is equal to 12. Okay, well, if y is equal to 0, then we have 4 times 0. Well, anything times 0 is just 0. So then we have negative 3x is equal to 12. So we can simply divide by both sides by negative 3 to find that x is equal to negative 4. Okay, so let's go ahead and put that in our table. Right, so this mystery number is negative 4. So we have the ordered pair negative 4, 0. And that blue dot right there is my x-intercept. Okay, so now all we have to do is find the y-intercept. So remember the y-intercept, we set x equal to 0. So we have 3x plus 4y is equal to 12. This time x is equal to 0. So we have negative 3 times 0 plus 4y is equal to 12. Anything times 0 is just 0. So we have 4y equals 12, divide by 4, we get y equals 3. Okay, so let's plot the point 0, 3. That's the point right here. Okay, and then if we're clever, we can again use technology or a pencil and a ruler to generate that line connecting those 2 points. And it's as simple as that. Okay, so again, the only difference between these examples and the ones we did at the first half of this video is that we are constrained to make y equal 0 and solve for x, that's our x-intercept, and then we have to set x equal to 0 and solve for y. So again, we can't willy-nilly pick any 2 points. We have to pick the point where x is equal to 0 and the point where y equals 0. Let's work on this next example. So again, we have to start by reminding ourselves that the x-intercept is found by setting y equal to 0 and solving for x. And the y-intercept is found by setting x equal to 0 and solving for y. So those are going to be the 2 ordered pairs that end up on our graph and that help us generate our line. So we have 5x minus 3y is equal to 15. Okay, so if y is equal to 0, we end up with 3 times 0, which of course is just 0. So we have 5x is equal to 15. Dividing both sides by 5, we find that x is equal to 3. So that means our x-intercept is at 3, 0. So that's that dot right there. Now we look at the y-intercept. So again, we have 5x minus 3y is 15. Okay, so this time we let x be equal to 0. So we have 5 times 0 minus 3y is equal to 15. So we have negative 3y is equal to 15. Be careful about the sign. It's very easy to forget, but he's still there, and he's going to change your answer. In other words, if you forget about him, you're going to get the wrong intercept. So 15 divided by negative 3 is negative 5. So then my y-intercept is 0, negative 5, which is this point right here. Then we just connect these 2 points. Let's see if I can do a better job. There we go. And that is our line. So let's do one more example. So now we have negative 2x plus 3y equals negative 6. Again, to find the x-intercept, we're going to set y equal to 0. To find the y-intercept, we're going to set x equal to 0. Okay, and those are the 2 ordered pairs that will help us generate our graph. So we have 2x plus 3 times 0 equals negative 6. So we have we have negative 2x equals negative 6. Divide both sides by negative 2, and we find out that x is positive 3. So our our x-intercept is 3, 0. Then, to find our y-intercept, we set x equal to 0. So we have negative 2 times 0 plus 3y is equal to negative 6. Okay, so we have 3y equals negative 6 divided by 3 divided by 3. We find out that y is equal to negative 2. Okay, so that's the point right there, and we can connect them with a line, and that's it.